Hey guys, welcome to Codeforces Everyday until GM Day 71, I believe. Today we are going to be working on this problem. This problem was recommended to me by a viewer. He has recommended me problems before. He was the one who recommended me cyclic merging, if y'all remember that problem. Now he is over here recommending customer service, and it is the highest rated problem I'm gonna be attempting. It is a 1600 rated problem. I think I've only done like maybe one 1500 problem, but he says that this one isn't too difficult and I should be able to get it. Hopefully I can get it. I've looked at it a little bit like last Friday, but I ran out of time, so I just kind of put it at the back burner and I was like, might as well record a video today. Just trying to solve this problem. But yeah, it has a lot of tags, graph matchings, greeting, math. Hopefully we'll be able to find some sort of solution to this. But yeah, let's just jump straight into it then. This person has started working as a queue manager. Okay, a queue called Black Contour. He needs to choose the order of servicing customers. There are a total of n queues, each initially containing 0 people in each of the next n moments of time. There are 2 sequential events. New customers arrive in all queues. More formally, the jth moment of time, the number of people in the ith queue increases by a positive integer, chooses exactly one of the queues and makes it 0. Okay, so if I understand this correctly, there's like multiple queues. Like some number of people enter the queue, each queue, and then we can choose one of these to make 0. Right, like boom, and then this guy's gone. And then what happened? Increases by, so next time x2, y2, z2, we add these, I think. Alright, so these are the queues. This is made 0, 0 plus x2, and then we can again choose another row to make 0. This person wants the max of the collection to be as large as possible. Help him determine the maximum value he can achieve with the optimal order of servicing the queues. Okay, so at the end, this should be like we'll have some value like ijk. Right, and we want to maximize max ijk. We've done mex problems before. Mex is basically just the smallest number that doesn't exist in the given array, right? 0 included. Okay. So reading this question was pretty straightforward. Let's take in some input. N equals int input, and then our queues for I in range n a equals list map int input split. Okay. So now the question is, do we want to take in the input first and compute, or do we want to do some pre-computation? per given array. So it's the max, right? So I have looked at this problem a little bit on Friday, and I was talking to my friend about it a little bit. He mentioned something about prefix. So, like looking at the arrays backwards and then creating prefix, like a prefix array. Right. Now, what does that mean? Okay, I need some theory on how this should work first before I consider anything. So in this first test case, 1, 2, 2, 1, max is 0, but we would be making one of these 0, right? Well, first let's just simulate taking it in. So let's file new canvas. So we have 1, 2, 2, 1. Q1, Q2. First, we take in 1, 2. Let's make which one do they recommend making 0? Second Q can be served at time 1. So we make this 0. And then this is time 1. And then we take in the next person. It's 3, 1. And then we can choose this guy to be 0. So then our max is 2. So, okay. Let me think. How can we do this with some sort of prefix array? Well, okay, so there's sums, right? Ignoring the zeroing out part. So we could prefix sum, like prefix sum it backwards. So this becomes 3. It'd be okay. It'd be 3, 1, and then the prefix sum of this would be 3, 2, and then what? We loop through and check for. We want it to be as great as possible. So like, do we just use a set? I'm thinking. Well, this test case is too small to see, but I'm thinking we can shove all this in a set, but I'm not sure if that zeros how I want it to. It might just work for this case, and we get 1, 2, 3, and then we would. No, that wouldn't work how I want it to. Well, if we set it to a set, I'm thinking, then we'll get something like 1, 2, 3, and then we replace however many. How many replacements do we do? So in, we replace in elements starting from the highest with 0. Right? Since n is 2, this would become 1, 0, 0. Okay, let's just keep this as a set. 1, 0, 0. And since this is a set, the 0 disappears. So it would just be 1, 0. And then we just sort the set 0, 1 and calculate the max off this. Now, does this work for every case? So I wish I had an actual whiteboard so I didn't have to remove this, but I'll remove it. Let me just remember. Okay, step 1, calculate prefix sum backwards. For all arrays. And then step 2, set prefix sums. Step 3, replace, or I can just remove highest in values. Step 4, max leftover and print. So this is my theory right now. We need to check if this part works for all given cases. So let's just check with a few more cases. Let's try 10, 10, 10, this 10 case here. So we are given 10, 10. Okay, so prefix sums is 2010, 2010. And then if we set, then we are given 10, 20. Remove highest in values. We just have an empty set. I guess we will have 0. Instead of remove highest in values, it's replace highest in values within, or with 0. And then max. Okay, so that works. 233441211. 233441211. 233441211. Prefix sum 678. 8. It's 8, 6. Wait. 8, 5, 2. 9, 8, 4. 4, 3, 2. And then set, we have 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 8, 9. And then we replace n is 3 with 0. So now we have 1. This isn't right. It should output 3. Oh, we are outputting 1. Why doesn't this work? We greedily replace the highest numbers with 0. Why is there no 1? Okay. I don't think this works because for this case we want to 0 this twice, or 0 this twice and get 1. Right? This is like unexpected behavior. So this just like breaks my entire strategy. How can we fix it? 4, 3, 2. Now, is this part that's broken? If this part that is broken, we have to fix everything after it. If it's just this part that's broken, that means we can salvage this part. How can we salvage this part? Two, three, four, 5. 6. We don't have 6. But 2, 3, 4, 5. We already have 2. And what is the proper way to find 3 according to this test case? 3. Third queue, second queue, then first queue. So they're saying 2, 4, 0, 0, 5, 1, 3, 1, 2. I see. Oh, well, this should be 0. Is this greedy at all? It is. Why am I thinking along the lines of backtracking then? Like, this can't be backtracking because it's greedy, right? Backtracking would be too slow. And then there's sortings as well. What does sortings do for us? Say we sort every array, right? Two, three, three. 1, 4, 4. 1, 1, 2. What does this tell me? Since we have two ones, we can remove either or. Okay, so say we sort and then we have a prefix sum. TS 5, 8, 6, 3. Is this gonna work? Can I even, like, I'm trying to figure out if these values are even possible. But this is 9, 8, 1. Oh, no, that's not even, because we ignore. It's 9, 8, 4. Having a 4 here isn't even possible, though. So, I don't think this is the case. Just because we sorted it, what does that mean? I think this is much more useful than this. Or than this. Okay, so let's new canvas because this is clearly wrong. And I need more room. 2, 3, 3. 1, 4, 4. 2, 3, 3, 1, or 4, 4, 1, 2, 1, 1. What can I do with this? Okay. Let's just look at it from behind. Or, okay, let's prefix sum them again. 6, 8, 5, 2, 9, 8, 4, 4, 3, 2. Right. Wait, did I fuck up my sorting? 2, 3, 3, 1, 4, 4, 1, 1, 2. Right. Take this, we can choose either. It doesn't matter. Why are they the exact same? Is there a case where it's not the exact same after sorting? This could just mean we don't need to sort at all, though. Alright, we'll look into that later. Let me finish this first train of thought. So first we look at this. we have 1. Our greatest is 3. So we have 0 and 1. And that means currently we replace the high. If we always replace the highest, that means we have 0 and 1. And then we look at this index. 1, 4, well, technically it's a second, what am I doing? Okay. Say I zero this one, then I zero Okay. Say I greedily zero the biggest. We have 8, 8, 4. Then we choose the first one because 5 is next. We have 2, 2. Right, 884 is our next potential max. We zero 5 because it's our next potential biggest. So the 0, 4, 3. And we're on 2, 4. We're on 0, 4, 3. Wait, what? Okay. Say we just greedily choose the biggest. Right? Then we have 5, 4, 1. Okay. 2, 4, 2, 0. 5, 4, 3, 0. 3, 5, 1, 0. Now we output 2. So this doesn't work. What they choose was 3, 2, 1. Why does 3, 2, 1? Maybe I'm thinking about this backwards. Why do I flip this prefix sum? Why not just have it? Why not just look at it backwards? Three, two, one. I'm thinking about guaranteeing existence now. I think sums are the correct play, but I think I'm missing something. If it's 0, 1, 2, 2, 4. Each state, right? Is the max sum from the start if they zeroed the next turn? Okay, wait. 2. Okay, so everything start should be 0. This is because everything could be zeroed at the end. Say, let's work on this guy since he's the easiest. If this was zeroed, his max is 1. If this is 0, his max is 2. If nothing is zeroed, his max is 4. This guy. This was zeroed, 1. This is zeroed, 5. Nothing, 8. This is zeroed, 3. This is zeroed, 6. Nothing, 8. This is supposed to be 9. Right. Now, if we set this, this isn't right. Now, these are all the possible things that these can be, which means now you choose well 0, 1, 2. Our max target is in, so our target is in, right, because there's only 3 columns. So we need a 0, we need a 1, and we need a 2. So we look at these. We count which one has a 2. This one has a 2. Well, we just look at I think we just set, and then we max the set, and if max set is greater than n, greater than or equal to n, print out n, else print max set. Might be it. Let's test it. What was the earlier case? 2, 1, 1, 2? 1, 2, 2, 1? All our possibilities are 0. And then for this one, if this was 0, we would have 2. If nothing is 0, we have 3. If this is 0, we have 1. If nothing is 0, we have 3. If this our thing, set is 0, 1, 2, 3. So we return, the max set is 4. 4 is greater than 2, so we return 2. Alright. 10, 10, 10, 10, 10, 10, 10. So we have 0, 10, 20, 0, 10, 20. Then now we have a set of 0, 10, 20, and so we output 1 is the max, right? And then now 42217 1931 42217 1931 55511 1211. Okay, now we have 0, 17, 19, 21, 25. We have 0, 1, 4, 13, 14. We have 0, 11, 16, 21, 26. And then we have 0, 1, 2, 4, 5. Now our target is 4. We have 0. This doesn't work, right? What's the answer? 3? Because we have 0, 1, 2. Does it work? Where's our 3? We don't have a 3. But also, what if this one didn't exist? There's a question that I'd like to ask. Like, what if this was a 2? 0, 2, 5. If it was a 2, it'd be 0, 2, 5, 14, 15. Now, would this work? Since we have no 1. I don't think this works. I don't think I can just set it. I need to use like an elimination bracket. Like if we choose one, we can't choose the other. So we look at the first n rows. So we don't even need to calculate the... Do we? I think we do. We look at the first n rows. Then we check from the end. What are we looking for? N. N in this case is 4. No 4. Pass. This has a 4. Okay. So now we're looking for 3. No 3. No 3. No 3. So now we start from here. We look for 3. No 3. So now our target is 2. No 2. Yes 2. Now our target is 1. Yes 1. Our target... We look, we find 4. We remove this row. We can't reuse this row. We check for 3. No 3s. We look for 3. No 3, no 3, no 3. Okay. We look for 2. No 2, no 2. 2. We can't reuse this row. We look for 1s. Can't reuse these rows. We look for 0. So we have 3 found. That is our max. Number found is our max. Now this is bad because this isn't squared. We check through every array. This is n cubed. We check through every array multiple times. So how can we actually optimize this? We look through. Can we do a counter per column? Does that do anything? No, because we need to not reuse columns. If we have an array, say we have this 2D array. Right. Traversing the 2D array is already n squared. This is genuinely hard. I don't really know where to think from here. N squared. So we're here. Zero, 1, 2. If we look at the maxes. we're looking for n equals 4. So no 4, 3. In this case, 3 is missing completely. So we get looking for 0, 1, 0, 1, 1, 1, 4, 1, 0, 1. We have 0, 1, 1, 1, 2, 1, 4, 1. So now, given this, what can we do? Choose 4. Choose 1. We choose from has choose 4. 4. We have 3. No. We could just set max for a case. It's like this. No, it doesn't work. Well, we could set max this. I still think it doesn't work though. Let's say there was no 1 in here. Then our max would just be 2. Select 1. So from this, we can select either of the useless. Now we select 1. These two have 1s. Since this one has 1 plus 1, we select this one. And we check 3. Since 3 doesn't exist, we output 3. So we just check for existence in the arrays we disable the arrays we're not allowed to use. What? This feels so slow though. So okay, so given how do we do this? Like we need to get to this somehow. First of all, I'm wondering if I can use combinatorics. Or like not combinatorics, like union. Python. Of n plus m. It's not union, it's intersection, that's what I meant. So for this is n squared. For each of these, we do r intersect with 0 to n. And then we should get, and then this should be n squared operation. And then let me think. Given 0, 0, 1, 4, 0, 0, 1, 2, 4, find next. So choose. Okay, we iterate through. We check if our current target is 0. Let's move this down a little bit. Our current target is 0. If I plus 1 exists, then we pass it. Else we use it. So let's greedily use this. And then we go to I plus 1. Now we greedily use this. And we go to 2. And then we use this. Now, I wonder, I have to play with like a few cases. Like 0, 0, 0, 0, 0, 1, 2, 4, 1, 2, 3. Greedily use this. They both have 1s. Do we just max each one? Max of this is 1. Max of this is okay. Max of this is 1. Max of this is 1. Max of this is 3. Max of this is 4. So we just select The lowest? Wait, then do we just... Zero. We select this and then select this. Then we select this. So it's 0, 1, 2. So this is the order. The max is the order of selection, I believe. So if we played around with a few more cases, like 1, 3, 1 or something. Select, we max them, 2, 1, 1, 2. Now we select, boom, and then boom. Then, okay, so 0, we're looking for 1. We look for 2, and 2 doesn't exist. Okay, there we go. So max 2, 1, 1, 2. You're selecting for 0. Biggest maxes go last. It's like 0, 1. Select for 2. Or select for 1. Can't even it's for 1. Oh, we skip, I guess, 1s, I guess. Select for 1. What? 0, 4, 0, 0, 1, 2, 4. Max is 1. Max is 2. Max is 1. Max is 3. Select for 0. Select for 1. Select lower always. Select for 2. Okay, for this case, select for 0. Select for 1. Select for 2. Oh, but this isn't even it. Like, these are duplicates. If they're duplicates, we can just select from. So, step 1, select from duplicates. Step 2, select the max. Step 1 is select from duplicates. Step 2, Select from max minus ones. Step 3, select from I don't want to recompute the max every time. Is there a way? Because I can, but that's like added time complexity again. Because getting here is n squared, getting the max is n. It's n squared again. I guess I can do this. I just don't know if this is going to be fast enough in general. Let's select from the max minus 1. And again, we have to modify arrays and remax. Step 3. Okay, so it needs to be like this. Lower max. Select lower max. Select higher max. And then all this go down. Append. Selection. And remix. So from dupe, select from max. Finding out there might be a dupe. Might be its only might be time complexity. Okay, so how do we figure out there's a dupe, first of all? That could also be like, we could have O2. This is 1. It's not max minus. This doesn't work. It's not max minus 1. Because it's like 0, 1, 2, 3, 4. Like something like this. Max is 3, 2, 1. So we're looking for a 1. Select 0. Max. Sorry, let's change this to like this. And then this is 2. Select max minus 1. It just doesn't work. Hmm. think any of this is right. I don't think any of this is right in general. All of this. All this must go. No. These I can keep. What does this tell me about Q's? Also, I should probably rearrange this. Be the same format. What's the answer to these two? They're both 3. This one's 1. This one is 2. We need 1. We'll always have a 0. Okay, let's play with some cases. So this always needs to happen. Like, we need a 1. This will happen. This has to happen. Or else, if this doesn't happen, we print 1. Now, what's the next step on this? Like, if we have... We can't use this. Okay, so instead of using x's, are for numbers we don't matter. We'll use zeros. We'll use z's as characters that we replace with 0. This don't matter, really. Does this not matter? This is a 0 character. Which means this doesn't matter. Like, any of these don't matter. Okay, so before the z, all of these don't matter. There's 1. We need a 2. So the only way numbers can't be 0, right? No. So we need this. This is guaranteed. We must have a 1 1. And to get a 3, we can have a no, because then we can't zero 2 rows at the same time. It's just this is the only possible thing. Wait. Is this it? The only way to get a 4, it's based on the number of ones at the end. Because if it's 2, 3, like it wouldn't matter, you can't zero that out. So say we didn't have this one, then we would just use this one. So actually it's the max of the number of wands in rows at at the very back. So we don't care if there's wands inside of this area. So we flip the array, or we don't have to flip it even. We can count backwards in the array and count the number of wands. Count the suffix ones. So step 1, count suffix ones. Then step 2, max step 1. Now does this work? Because say this line was missing. Then the answer would be 4. Huh? Give me a sec. Oh. 4. It's the count of ones. It's not. It's the length of the array, not the max of the array. It's not. It's not specifically the length of the array, because this could exist. A duplicate. So it's the set of the count of ones. It's the length of the set of the count of ones. Is this right? The length of the set of the count of ones. Length of the set of the count of ones. Say this one didn't exist. 0, 1, and this one did exist. So we'd have 0, 1, 2, 2, or 0, it'd be 0, 1, 1, 2, 4, right? Set 1, 2, 4, so our answer would be 4, minus 1, 3. I think this works. I can try it. First we need to count suffix 1s. Okay. Okay. Please work. One. Why is it so slow? Oh my god, bro. I cannot. What is wrong with this? Wrong answer. Fourth. Expected to found one. One, two, three. This case. Why does this output one? So we get 2, 2. Then we set it. It's 1. So, okay, this actually doesn't work. You're right. But in a situation where it's like, okay, what's the most minimal case? Well, actually 0, 1. Well, what can we do in this case? 0, 0, 1. Do we just plus 1? No. Because if 0 exists, then we don't need to account for it. Okay, so we have our suffix 1s. We need to look for the cases. Let's view. We have our array of suffix 1s. Case 1 contains 0. Something like this. Case 2 doesn't contain 0. Text. Case 3 contains duplicate at the end. Case 4 doesn't contain duplicate. It contains duplicate in the center. Case 1, we have 0, 1. Our set is 0, 1. Our len set goes 2. This one, we have 1, 2. Our set is 1, 2 equals 2. This one, we have 1, 3, 3. Our set is 1, 3. Our answer equals 2. Is 0, 1, 2. Our answer is 3 though. Okay, so this behavior is not actually len set. It's we have 1, 3, 3. And then we compare to 0, 1, 2. And then if something doesn't work, that's our index. And we check if, okay, A, B. If A, I is greater than or equal to B, I, else print I. So this was 4. Or say this was 1. Okay, never mind. Say this was a little longer. So I have like 4, maybe like 3, 3, 3, 2, 1, 1 or something. Greater works, 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 done work, so we just print I. So basically if it's, just to fix up this logic, if AI is less than BI, print I. And then in this case, it's 1, 1, 2, 0, 1, 2, works, 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 so it's just 3. Else, this is 4, else it's in. This is the important part, I think. These are, I think all of these work for this. 0, 1, 1, 2. Okay, yeah. Let me move this to my other monitor. I can code this. So to check I, print I, break. This doesn't work now. Auto-ported range. Oh, okay, what is going on here? Here we go. Two, one, three, one. Why is this case failing? We have suffix 1s as 0, 0, 1, 2, 0, 1, 2, 3. We output 1 because it's where it fails. Well, duplicates. Higher duplicates are appreciated, but lower duplicates are not. If So we check if suffix 1's I exists. How do you spell incrementer? This is right. Incrementer equals 0. try this. Catch. How the fuck do you use try in Python? Or try accept. Zero, zero, 01. We literally have this case right here. Why does this happen? 0 plus 0, n is 2. So we go here. I, 0. It's not less than. So we skip this. Go again. 1, 0. Go here. Suffix 1 is 0. To check 1. It is. So 2 print is equal to 1. Incrementer equals 1. Go through. None. none, 1, 2. Go through this twice. Oh. It's over. Already swapped now. You're none. 1. 1. Now why when you come out, you are 2? Ants never prints. Oh, it's because there's no break in here. There's a break here, but might not hit it. So now the question is, do I even need this? Ants is not. Let's remove these. None, 1, none, 1. This ain't right, bruh. I need to hit a print in here and break. somehow. Let's just remove all this stuff. Okay. Then I add if to print not to print to print equals in. Like this. No. This last case. Is 0, 0, 1, 2, 0, 1, 2, 3. What's wrong with this? Oh, wait, do we even need to? I don't think we need to do this. This is 0, 1, 2. We just increment like an incrementer, and then check if it exists in the array, no? Yeah, this is overcomplicated. Like a to print. I don't even think we need this. To print equals 0. And then for in suffix ones, if to print greater than or equal to in, to print plus equals 1, and then print just this, no? Okay, 2, 1, 3, 4. For in suffix ones, to print is 0. 0. 0 greater than or equal to 0. 1. Didn't fix anything. No. Oh, these are in the wrong places. Two birds here and here. Yes, yes, yes. Okay. Okay. Oh my god, we got it. This was a 2-hour long question. I'm gonna call it here, guys. If y'all enjoyed this video, be sure to like and subscribe. I'll see y'all guys tomorrow. Bye.